with 14 degrees of freedom too, right? 0.034. Okay, so the conclude, listen to the conclude. I want you to write it down. With a p-value this low, we have sufficient evidence to reject the null hypothesis and say the express lane is faster than the regular lane. Okay? With a p-value this low, there is sufficient evidence to say the express lane is faster than the regular lane. All right. Final steps here, final steps. Significant tests are widely used in reporting research. New drugs require significant evidence. It's got to be significant. Okay? Statistical significance is not the same as practical importance. Pay attention to the actual data as well as the p-value. So even though that something, follows the test, it doesn't make sense all the time. Okay? Here's an example. Okay, curriculum reform. What do I got left? 6 minutes. Suppose that a large school district implemented a new math curriculum for the current school year to see if the new curriculum is effective. The district randomly selects 500 students and compares their scores. The mean improvement was 0.9 with a standard deviation of 12. Calculate the test statistic in p-value. Okay, so let's do that. Let's calculate the test statistic and a p-value for that. So let me get a piece of paper. Okay, and you guys can see that up there. Test statistic and a p-value. So they want to know if it's greater than. So let's see. We're saying that there was no change, right? So t equals, the change we found in our sample was 0.9 minus 0 over the standard deviation, which is 12, divided by the square root of 500. So when we do that out, guys, this is what we get. We get a t-score of 1.68. So we do the old TCDF, 1.68 to 999 with degrees of freedom 499, and we're going to get 0.047. 0.047. So are the results significant at the 5% level? Yes. Okay, so this is 0.047 is less than 0.05, but it's pretty close. Okay? Can we conclude the new curriculum is the cause of the apparent increase in scores? No. Yeah, how are you going to know that? It's too close. Okay? We can't conclude it was. There was no control group. There was no random assignment. There was lots of other things. Plus, it was really close. For a school to make this decision and change their curriculum, it's a huge, huge monetary thing. And to be something where they don't have a good enough test, no. Given you want to know the average GPA of students at your school enrolled in AP statistics, since this is a large population, you can make a census for the GPA for each student. Is it appropriate to construct a one-sample T interval for the population mean GPA? Okay? And no, if we have the GPAs, we can get the exact answer. That doesn't make sense. Okay, it doesn't make sense. Well, if you have a census, why would you go through and do a test? You have all the information. Suppose that 20 significance tests were conducted in each case. The null hypothesis was true. What's the probability we avoid a type 1 error? Well, a type 1 error is 5%, right? So avoiding a type 1 error is 95%. And then we have to take that to the 20th power, and we would get 0.36. All right? Here we go. Yeah, we're good. We're good. We're good. We finished the game. We finished the game. Boy, 9-3 took me a long time. time. 9-3 took me a long time. Thanks for hanging in, guys. I appreciate it.